Good day, grade 10s. Today we are going to be doing algebra. It's going to be an exam revision of algebra. And I hope you are aware that algebra is found in paper 1. And it constitutes more than 25% of your paper 1. So by the end of this lesson, grade 10s, you will know exactly what are we talking about when we talk about expressions, of which I know you know by now. We are going to be talking about what as well? We are going to be talking about exponents. By the end of this lesson, we are going to be talking about equations, then inequalities. So that covers everything that we are going to talk about today. Wait, I didn't read it. Okay, grade 10s. I hope I've already stated our lesson objectives. So I want us to remind ourselves of the number system. So that was the first thing that you were introduced to in mathematics grade 10. So we refer to this as the real number system because all of these numbers that we are going to talk about are going to be under the real number system. And mathematics from grade 10 all the way to grade 12 will be based on the real number system. It means every number that you see, you need to know where it comes from, what is it. So already here you can see we have our natural numbers. The natural numbers are more like the counting numbers. So whenever you want to count, how many are we in this class? Of course, you're going to say 1, 2, and so on and so forth. So it means the natural numbers are the counting numbers. For example, 1, 2, 3, going on and forth. It means 0 does not fall under the natural numbers. 0 does not fall under these natural numbers. I think I've mentioned that. So of course, moving on from natural numbers, we're going to move to whole numbers. Now you need to know the difference between whole numbers and natural numbers. There is a very tiny difference between these natural numbers as well as whole numbers. And what's the difference? It's 0. So it means the whole numbers, they start from 0, then go to 1, 2, 3, so on and so forth. So already we have our natural numbers mentioned here, then here, we have our natural numbers mentioned here, then we have our whole numbers mentioned there. So let me write it down so that you see what's happening. These are our natural numbers. These are our whole numbers. So from natural numbers to whole numbers, we'll move on now to integers. Integers are the ones that starts from negative whatever all the way to negative 3, negative 2, negative 1, 0, 1, 2, 3. So you can see the difference now. There is a bit of a difference between the integers and the whole numbers. It's just here there are negative numbers, here there are no negative numbers. But 0 is also included with integers. We've spoken about natural numbers, spoken about whole numbers, spoken about integers. Now let's talk about these ones, rational numbers. First, let me write to show you these are integers. Okay, here, these are what? These are our rational numbers. Do not be scared by that Q that you see there. It does not mean Q. It means the rational numbers. So the rational numbers are all those numbers that you can write as a fraction. So if you see a number and you are able to write it as a fraction, it means we are talking about rational numbers. Then from all those, you are going to move on to irrational numbers. So these ones are those ones that you cannot be able to write as a fraction. For example, 0, 1, 2, 3, 4, 5. I don't think there's a way of writing this as a fraction. So it is referred to as an irrational number. We're going to move on. I hope you understand the real number system. So this real number system, you are going to apply it for the rest of your further education and training life. Meaning for the rest of your FET life, grade 10, 11, and 12. Even beyond, you can still use the real number system. I hope everything is clear thus far. So let me wipe here and talk about expressions. As I promised you that I'm going to be talking about expressions, but it was necessary for me to mention the number system because they're gonna ask you in the exam. So at least I will have done my work. Now, pretend it is very important for you to know the difference between expressions, equations, and inequalities as we move on with the lesson. But we're going to clarify those differences very, very well. So as I said, we are introducing ourselves now to expressions. It's not even introducing ourselves, it's just a matter of revision of expressions. I hope you are aware that anything that can be written in the form ax squared, maybe, plus bx plus c is an expression. Why? Because there is no equal sign, there is no inequality sign, so it simply means you are talking about an expression. So this is an expression. If maybe there was something like this, equal there, so it was going to be an equation. If I started to add something so funny like this, maybe it was now going to be an inequality. But when it's like this, meaning there is no equal sign, there is no inequality sign, we are referring to this as an expression. However, an expression is made up of terms. I can have something like this. It's a term. And it's only one term. And we refer to it as monomial. But you are saying, I don't see one variable there. No, it's a term because there is no operation sign between this term and the other. So this one is referred to as a monomial because it's only one term. Then if maybe I have something like this, ax squared maybe plus b, now it's no longer a monomial. It's also terms, but now these terms are referred to what? As binomials. And then here you can see, okay, 1, 2, 3. It means we have 3 terms here. So this one then we refer to it as a what? As a trinomial. Now it's very important that from grade 10 you know all this. This is a monomial, a binomial, a trinomial. Because as you move on with your life in the FET life, like in further education and training, you will hear words such as monomial, binomial, a trinomial. They must not scare you anymore. This is what they mean. Even if maybe, for example, there was a minus sign here, still, it was going to be a trinomial. Even if there was a minus sign here, it was still going to be a binomial. So it means whatever separates the terms, for as long as it is an operational sign, most specifically a plus and a minus, it means now it's a trinomial or a binomial. As long as there is something separating there, like for example here, we're having ax squared minus b. There is an operation sign here separating the 2 terms, making it a binomial. 3 terms separated by 2 operational signs here, trinomial. I hope everything is clear now. You understand everything about expressions. We are going to move on. I promise you that by the end of this lesson, you must understand thoroughly what are we talking about when we talk about an expression. So, what exactly did we want to achieve with expressions? Well, with expressions, it's very easy. It's very nice. All you have to do, you have to know how to do 2 things, only 2 things with expressions. You need to know how to simplify your expressions. You need to know how to factorize your expressions. That's all you need. Whenever you are given an expression, you must have the ability to simplify, you must have the ability to factorize. Now, what does it mean to simplify? To simplify is more like, obviously, the word is self-explanatory. You are simplifying whatever you are given to its simplest form. Meaning, it's more like you are getting rid of brackets. I hope I've done my work. I taught you about binomials and trinomials. Now you know all those terms. For example, let's say we're having a plus b. So this is a binomial. A plus b plus c. This is a trinomial. So here you can see we are having brackets, but when we simplify this, we're gonna apply what we call the distribution law that you've done in grade 4 or back then. So you're gonna apply that distribution law to make this in its simplest form. And whatever product that you're going to get, whatever answer that you're going to get, it must not have brackets because we have simplified to the simplest form. You have got rid of the what? Of the brackets. That's all you do with simplification. It can be squaring of binomials. It can be a product of binomial and a trinomial. It can be maybe, oh, this is what I was saying when I was saying squaring of binomials. This is squaring of binomial. Maybe you're having a plus b, I mean a plus b. This is a binomial, this is a binomial. You can write this as a plus b squared. It means what you are doing, you are squaring binomials. You want this to be in its simplest form, right? Let me move on. So I hope you understand what is happening with simplification. Then we'll move on to what? To factorization. Factorization is somehow more like the opposite of simplification. Here, you are not getting rid of the brackets, you are doing what? You are bringing back the what? The brackets. You are factorizing, you are looking for factors that when you multiply them together, they must give you a particular what? A particular answer, a particular product. So to factorize is more like to bring back brackets. For example, you'll be having something maybe like, let me say, x squared minus 2x plus 1. You'll be having something like that. It's an expression because there is no equal sign, there is no inequality sign. It's an expression. So what can you do with this expression? You can simplify it, you can factorize it. Then this is what you'll end up with, x minus 1, something like that. I'll leave it there for now.
Morning, grade 10s. I'll be one of your core teachers today. I'll be continuing where the other teacher left off, whereby I'll be treating examples or equations. So here on the board we have 5x plus 1, close brackets, open brackets, 2x squared minus 3x minus 1. So here we'll be simplifying. So what we're gonna do is we're gonna this bracket, they represent multiplication. It's just that they don't write the multiplication, but you should just know that when you see a bracket, you see multiplication. So we're gonna multiply these with these. So how are we gonna do it? Firstly, I want you guys to try it on your own. Then I'm gonna show you the correct procedure of doing it. You can pause the video to do that. Here we're having 5x plus 1. So what you're going to do is firstly multiply this 5x with the whole of this trinomial here. So I'm starting now. You're going to say 5x multiplied by 2x squared, which is 10x to the power 3. Then you're going to say 5x multiplied by minus 3x. Right? And you should remember that when you're multiplying a positive and a negative, you're having a negative. So meaning that your sign here will be what? Will be negative. Then you're saying 5x times 3x, which is gonna be 15x squared. Then we're gonna say 5x multiplied by minus 1. Again, you know that when you're multiplying a positive with a negative, you're having a negative. Then from there, you're going to say 5x multiplied by 1, which is what? 5x. Then you're done with 5x. Then you move to the positive one. Here you're going to say positive 1 multiplied by positive 2x squared. We're having, you know that any number multiplied by 1 is that number. So you're going to have 2x squared. Then again, it's positive 1 multiplied by negative 3x. And you know that when you multiply a positive, like I said, a positive multiplied by a negative, it's a negative. So you're going to have minus 3x. Because again, you're multiplying a number by 1. Then 1 multiplied by minus 1, it's we having minus 1 again. So when you look at this, you have to look for like terms. You're gonna group them in like terms. Before you do anything, just group them in like terms first. So you see that the first bigger number is 3 as an exponent here. So you're gonna look for another exponent which is 3, which is not there. So it means that you're only having 10x to the power 3. Then again, you could see that you're having 15x squared along with 2x squared. So what you're gonna do, you see that these two are like terms. So you're gonna group them together. Then again, we have in minus 5x and minus 2x. You can see that they are also like terms. You have to group them again. And there's only one number there, which is minus 1. Then it's gonna be a lonely. Then from there, that is when you're gonna either add or subtract. I'll be using my calculator, by the way. Then we're having minus 15 plus 2, which is gonna be minus 13x squared. Here we're no longer multiplying. It's either you're adding or you're subtracting. Then we're having minus 5x minus 3, which is minus 8x minus 1. So here I think I'm done with my, I'm actually done, I'm not thinking, I'm done with my simplifying because they are no longer like terms here. Each number, it looks like itself. There's no number that I can add or subtract here. It means I'm done with example 1. Grade 10s, we'll be continuing with simplifying, right? So right now here we're having our expression, and this expression it's exponent, right? And then what we're gonna do here, the first thing to do is to make this basis in their smallest prime number. So before I continue, you can also use your calculator to find the factors. The smallest prime number of 9 is 3 squared, and we're having that as x plus 1 multiplied by 5x plus 2. We can't change 5, right? So we move to 45, which is giving us 3 squared multiplied by 5, all to the power x plus 1. So what you do here is that you're gonna multiply the exponents. So we're having 3 2 times x and 2 times 1. So what you're going to do here is 2 multiplied by x, which is 2x, 2 multiplied by 1, which is 2 multiplied by 5x plus 2, all divided by, here we're having a multiplication, but we're going to multiply the exponents of this basis with their power. So what we have here on the exponent for 5 is 1, but they don't usually put it there. You should just know that when you see a number, it has an exponent which is 1. So we're having 3, then 2 times x and 2 times 1, which is 2x plus 2, multiplied by 1 times x and 1 times 1. Which is 5 to the power x plus 1. So here, you know that when you, okay, firstly you have to look if they are like terms, the ones that can cancel each other out. which is 3x squared plus 3 to the power 2x plus 2. Even under the division side, we have 3 to the power 2x plus 2, which they can cancel themselves out. Then on our expression, we'll be left with 5 to the power x plus 2 divided by 5 to the power x plus 1. So what you're going to do here is that you're having an exponent, exponents, right, with the same basis. And you know that one of the laws of the exponents is that when you're having exponents of the same basis, you do what? You subtract the exponents. So what you're gonna do here is 5x plus 2, it's gonna minus x plus 1. So it's gonna be, firstly you have to this is an important sign whereby you have to multiply everything that is in bracket with the minus. So we're gonna be left with x plus 2 minus x minus 1, whereby x minus x is 0, then 2 minus 1, you are left with what? You are left with 5 to the power 1, which is the same as 5. So we will be done here with this one. So on this part, we'll be learning how to factorize, right? By now, I'm aware that you guys know that when you're factorizing, when you're factorizing a trinomial, this is a trinomial, right guys? This is a trinomial. When you're factorizing a trinomial, you know that this, it's C, right? You find the factors of C that when you multiply them, they give you C, but when you add or subtract them, they give you the middle term, right? So on 4, the factors we're having 4 times 1, we're having 2 times 2, right? So 2 times 2, you can already see that 2 plus 2 can never give you 3, or 2 minus 2 can never give you 3. So you're going to scratch them out. So here you're left with 4 and 1, right? So you're going to open your brackets. You having x, you having x. You having 4, you having 1. So here what you're going to do, which is more simpler, other people like saying, when you get to this point, the bigger number is the one that gets the middle side, which is a minus. Meaning that here you'll be having a plus. So this was like simply learning how to factorize, and then when you are here, you are done. There's no need to continue with simplifying. This is factorization. You leave them in brackets like this. So here when we continue with our factorization, right? Here we're having difference of 2 squares, whereby this is a perfect square, right? So what you're gonna do here, grade 10s, is you're gonna open brackets like this. When you open bracket like this, you're gonna have an x here, and then you know that when you're dealing with difference of 2 squares, you're gonna have 2 different signs in your brackets, meaning that here you're gonna have a plus, here you're gonna have a minus. Then you're gonna take your calculators, then check the square root of 81, which is 9, right? And you know the square root of 81, not 9, 81, which is plus or minus, right? Which is plus or minus 9. Then from here, you're going to have a plus 9 and a minus 9. So this is the simplest way of dealing with the difference of 2 squares. Thank you. And bear in mind that everything that I was doing with you guys, it was all about expressions. Thank you.
Hello, grade 10s. My name is Lepepana Ramgayan, and today I'll be dealing with the content of equations and inequalities.
Equations and
inequalities. Before going deeper with the content, we have to know the definitions of equations and inequalities. What is meant by an equation? We can say an equation is, sorry about it, is an expression whereby two values are compared by an equal sign. We have been dealing with math since from primary, and I guess and I understand that you know the symbols for math: division, addition, subtraction, equal sign. So the equal sign, it has to remind you of an equation. Equal equation, you say the rhyming words: equation, equal, equation, equal. You understand? So for example, an equation we said is an expression whereby two values are compared by an equal sign. Let's think about any equation that comes into your mind. A simple one. Okay, 2 plus 3 equals to 5. This is an equation. Why? Because of the equal sign. Okay, and in primary they were doing things like this. They would be like a box plus 3 equals to 5. A box plus 3 equals to 5. And then you have to think literally that which number can I add to 3 so that it can give me 5? It's what? It's 2. It's 2. This thing leads us to solving equations. Solving equations. During this stage of yours, grade 10, FET of yours, the box is replaced by either X, Y, Z, or any letter, and then we call them variables. We call them variables, okay? Then it would be like, let's use X because it's the one that we use it frequently. X plus 3 equals to 5. X plus 3 equals to 5. And then, remember, in primary you were thinking literally that which number can I add to 3 so that it can give me 5. But in this stage of yours, you have to say X equals to 5. When you see plus, what is the opposite of plus? The opposite of plus is minus. And then what's the opposite of division? The opposite of division is multiply. Okay, so since the opposite of plus is minus, hence this side will transpose the 3 to this side. Minus 3. Why? Because the opposite of plus is minus. Then equals to 2. You see, it means that our x is going to be equals to 2. Okay. However, there are 5 types of equations. The first one is linear. The first one is linear. This is the type of linear equation. Why? Because it is straight, it is not complicated, it's just linear. Okay. Then the second one, let's go to quadratic. Quadratic equations. Or due to time, you can see that. Quadratic equations. Okay. When we deal with quadratic equations, the general formula for quadratic equations is ax squared plus bx plus c equals to 0. This is an equation. Why? Remember the equal sign. It has to remind you of and equations. Okay, so these ones are the coefficients. A and B are coefficients. A coefficient is a number that comes before a variable. Sorry, sorry about that. A and B are coefficients. We say a coefficient is a number that comes before a variable. What do we say a variable is? A variable is any letter, A, B, C, D, E, F, G, any letter. It's called a variable. And then this one, it's C. It's alone. There is no variable. There is nothing. We call it a constant. However, when we solve quadratic equations, we have to use quadratic formula. Quadratic formula, or complete the square, or factorize to solve. Since I'm dealing with the content, I'm not going to go deeper with the examples and all stuff, but for at least one example, let's use x squared, for example, 1. X squared minus 3x minus 4 equals to 0. Okay, then the question says solve for x, and then you see equals to 0. How am I going to do that? It's simple. You apply the rules of the laws of exponent. You factorize. Open the brackets, the two brackets equals to 0. And then you factorize this one. X squared is the same as x times x. Then you put x here, you put x here. And then the problem comes here. And then how am I going to deal with this one? You look at 4, you look at 3, the last term and the middle term. You have to think about two numbers. When you add them, they have to give you minus 3. When you multiply them, they have to give you minus 4. What are those numbers? You must think, literally, you must think. Okay, let's check 4. Vectors of 4, 1, 2, and 4. Let's see. It has to give you minus 4, okay? Let's take this one. Minus 1 times 4, how much is it? Minus 1 times 4 is minus 4. Good, it gives us minus 4. But then, minus 1 plus 4, how much is it? Minus 1 plus 4. It's positive 3. Oh my gosh, it's not working. Let's remove this one. Let's say positive 1 and minus 4. How much is it? It's negative 4. Wow, it's perfect. Then 1 plus minus 4. How much is it? Minus 3. Good, this one is working. Then you can say plus 1 and then minus 4 equals to 0. Minus 1 times minus 4, it's minus 4. Minus 1 plus minus 4, how much is it? It's minus 3. Okay, then now you can solve the equation. X plus 1 equals to 0, or x minus 4 equals to 0. Then you solve. Now you go back to your linear. You see now your equation is linear. Then it's equals to 0 minus 1. It's how much? Minus 1. Or x equals to 0 plus 4. How much is it? It's positive 4. Now, to be sure, you take your calculator and then substitute these numbers and see, do they exactly give you 0? If they don't give you 0, just know your work is not perfect. Let's check. Minus 1. Then it's minus 1 all squared minus 3 into minus 1. You substitute. Where you see x, you put minus 1. Minus 4. Yeah, it's working. Why? Because whenever we substitute minus 1, it gives us 0. Let's check if we're at positive 4, it works. 4 squared minus 3 into positive 4 minus 4. Perfect, it works, meaning that our work was good. Now, we were doing quadratic equation. Or you can use the quadratic formula in order to factorize. So quickly. Then quadratic formula. Quadratic formula is a formula that we can use. The first thing when you deal with quadratic equations, you have to start with the factorize method to solve. If you cannot factorize, then you jump into quadratic formula. And this one is perfect because your work. Let's cover the last topic under algebra, which is inequalities. Inequality, how can you define an inequality? An inequality is an expression whereby two values are compared by an inequality sign. What do we mean by inequality sign? We have strictly greater than, strictly less than, greater or equal to, less or equal to. How can you actually differentiate these two? Remember, greater, this one, use your right hand. Your right hand is stronger, meaning that it's greater. You know, something that is strong, it's greater than. Then less than, you use your left hand. You see, your left hand is not that, it's weak, actually, so it's less than. So that's how you can differentiate them. That's the best way you can differentiate them. So the last example under inequality, we can use x squared minus 3x minus 4 is greater than 0. What are we supposed to do here? First thing, you have to factorize. X, we said minus, okay, sorry about it, 0. Yeah? We had to think about this. Minus 4 plus 1. Let's see. Minus 4 plus 1, how much is it? Yeah, it's perfect. It's perfect. So you have to find the critical values. Critical values. X equals to 4 and x equals to minus 1. Then you draw your number line. You put the lowest, minus 1, 4. And then you know these are the numbers that are less than minus 1. These are the numbers that are greater than 4. And then these are numbers that are in the middle. 4. And then you go here. Greater is something that is positive. Anything that is greater than 0 is what? It's positive. Then this side is always positive, then negative. Then you choose it. The equation says it has to be greater than 0. Anything that is greater than 0, it's positive. Therefore, your inequality sign, it's x is less than minus 1, or x is greater than 4. I hope you understood. Thank you. I hope you understood.
Now, since you guys have already done and saw what exactly we're talking about, which are your equations and your inequalities, what I'm going to do with you guys is show you how you would solve them if you need them. So the first ones that we're going to do are your linear equations. Now, a basic example of a linear equation that I can give you is 2x plus, let's say 2x plus 2 is equals to 1. This is a linear equation. And the basis here, what you need to do is solve for x. And what you have to do, what I like to do, I like to group. So group like terms. So a like term, I think many of you guys know like terms are the ones that are the same. So 2x has no other term that is exactly like it. But this numeric number is the same, so it doesn't have anything on it. So it will go 2. So we would say 2x is equals to 1 minus 2. Because when you take a number to the other side, we divide it. Or, if you don't want to say taking a number to the other side, you can say minus 2 this side and minus 2 this side. And this would give you 2x is equals to 1 minus 2, which is 2x is equals to negative 1. And this would give you x is equals to negative 1 over 2. I think you see what I did there. So this was an example of a linear equation. But linear equations aren't exactly this easy. Because, let me give you this example. Let's say you were given an example such as, let's say px plus qx is equals to a. And they say in such a situation, solve for x. You have to do the same procedure. In the same procedure, you just need to solve for x. Now, something that you've already done and you saw, which is, now, how would you approach this? Now, there are no like terms in this situation, but we want this x. So we can do something that you've already done, which is factorizing, and we can just take out this x, and then we'd have p plus q is equals to a, and then we'd divide this and isolate x, and thus we'd have p plus q is equals to a. Sorry. A over p plus q is equals to x. Now this, so in the same way, this is still a linear equation, but it just needed other things. And you were doing the same thing, which was solving it. So let me do another example that you might see. So here is an example that another example that requires something that you have touched on, which is an expression. So we would have 4 into the brackets 2x minus 9 minus 4x is equals to 4 minus 6x. 4 minus 6x. Now this is something that you've already done in the first part of the video, which was expressions here. Now, one of the reasons why you need to start with this, it brings us back to that old rule of BODMAS. Alright, so now this is an example that we're going to do now. And in this example, it has a lot of things that you can do, but where we're going to start is the brackets, following the old one of the rules of maths, which is BODMAS, and B standing for brackets. And since you've already done this in the earlier parts of the video, you first start here, so that we can have our like terms, and so we would expand it. So how would we expand it? Something that you've already done. You'd say this there, this into that. Then we would expand this. This would be 8x minus 36, and thus we have the complete part, which is 4x to x squared. Something that I said that we have to do here, which is grouping like terms. So now we need to group the like terms of this equation. So which ones are the like terms? This one is a like term. So these ones are the like terms, and we need to group these ones in one side, and then we'll group this one and this one on the other side. So we'll have our 8x minus 4x. And remember what I said, when we take a number from the other side and we take it to the other side, it changes its sign, and thus we have 6x. This will have 4 plus 36. Now, we can work this out. This will obviously be 4x plus 6, 10x. And this would be 4 plus 36, and that would give you 40. And thus, remember what we need to do. So for x is equals to 4. So one of the nice things in equations, to test out the answer that you got, you can always take the x and put it back into the original equation. You can take this and you can sub it in the original equation. And the original equation that we have here is this one. This one is the one that we're talking about. So if you want to check whether your answer was correct, so what you need to do, we'll take the side, 4 into 2x minus 9 minus 4x is equals to 4 minus 6x. So now we can substitute the 4 that we got here. 4 into 2 minus 9 is 4 into this equals to 4. So what did we do here? Everywhere where there was an x, we put our 4 in there. So here we would have 4 into 8, 8 minus 9, 8 minus 9 minus 1 minus 16 is equals to 4 minus 24. So thus we would have negative 4 minus 16, and this would give us negative 20, and this side it will give us negative 22. So now we can see that which side? The right hand side is the same as the left hand side, thus x is 4, as we have concluded. Alright, so now let's do a bit more complicated one, because when it comes to equations like this, we never necessarily state in one thing. So another example of a linear equation is one that is in a fraction form. So we can have 2 minus x over 3x plus 1 is equals to 2. So in this form, standard procedure, What we're looking for, we want to solve for x. We want to solve for x. But now this linear equation that we have is in a fraction form. So how would we solve it? Now this one's one of the easier ones, because when you have it in this way, we can just cross multiply. Remember, when you have your 2 like this is the same as 2 over 1. And cross multiplying it means that we're gonna multiply this denominator with this numerator and this denominator with that numerator. So we're gonna say 2 times 3x plus 1 is equals to 2x minus 1. Minus x, sorry. And this is what we did, and that is what we're doing. So now we have our standard linear equation. We can solve, we can expand our brackets. This will be 6x plus 2 is equals to 2 minus x. Remember what we do next? Our like terms. So we take our 6, we plus it with x, and we have our 2 minus 2. And thus here we'll have 7x is equals to 0. And in any equation in maths, when you have 0 divided by a number, you'll always get 0. X will be 0. Because an example that what you know is that when you divide any number by 0, you get an undefined answer. But when you take 0 and you divide it by a number, you'll always get 0. Because when you take that number, for example, when we take these zeros and add 0 plus 0 plus 0 plus 0, we'll get 0. So in this equation, the answer x is equals to 0. So if you wanted to check it out, you just substitute this into the original equation. So we'll just say 2x over 3x plus 1 is equals to 2. So we'll just substitute 0 where we see x. So 2 minus 0 over 3 times 0. And we can see that the answer here is definitely 2 over 1, which is 2. So we can see that yes, this side, remember, the right-hand side is the same as the left-hand side. So that is a standard linear equation. It's usually the one that you have. So let me do another linear equation that would require you to find something that we call the lowest, something we need to find, which is the lowest common denominator. Now in our linear equations, we'll have a linear equation such as 3c, let's say 3c over 10 plus, let's say, okay, 3c over 10 is equals to 4c over 15 plus 1. Now, this is the same thing. It's still a linear equation, but it's a bit different because now we have different denominators. And you remember in fractions, we need the same denominator because we can just take this. What we could do, we could just take this and bring it this side, but we have different denominators. So what we need to find now is something called the LCD, the lowest common denominator. When you have an equation like this, you need to find the LCD because it's going to help you to solve the equation. So now how do we find the LCD? So now we have 10 and 15. We just need to find the factors of 10 and 15, where will be one that will be the same. So we'll start from these numbers. So we'll have, in this, let's say we'll have 20, 30, just going like that. And here we'll have 15, 30, 45, 60, 40 here. So now when you look at these multiples of these numbers, you can see that 30 is here and it's here. And these are the lowest common multiples. So we take these lowest common multiples and we multiply them in these denominators. So we take 30. Now 30 in this equation becomes the LCD, which is the lowest common denominator, which is 30. So on the side you'll write my LCD is 30. So what does that mean? You need to take 30 and multiply it in each equation. So for example, you'll say 3c over 10 times 30 is equals to 4c over 15 times 30 plus 1 times 30. So if we'd work here, we'd know that we know that 10, when 10 has to go to 30, we'll go 3 times. So we'll say 3 into 3c is equals to 15 into 30. We know that that's 2 times. So we'll have 2 into 4c. And 1 into 30 happens once, which will be just 30. So now, what do we have here? We have a standard linear equation. We can expand the brackets. 9c, 8c plus 30. Take our like terms. Minus 8c is equals to 30. We'll have c is equals to 30. So in this example that I just did here with you, we can see that c is equals to 30. Now, another form of equations that we do are what we call our quadratic equations. Now, your quadratic equations are similar to those of trinomial. Because in a quadratic equation, we have, for example, we'll have 2x squared plus 2x is equals to 1. So, you would say blindly that this is a linear equation. But the issue that we have here is that we do not have any like terms. But if we do it like this, we can see if you hide this equals to 0, you can see that this is a trinomial, something that you've already touched on in the video. This is a trinomial. So we can solve this as you would solve a trinomial, which is to factorize it. Alright, so in our closing, we're just going to do these last 3 examples. They are taken from a past paper of yours. I'm just going to show you how you would solve them, how you would go about them. I'm not going to do it step to step. In maths, you need to move. So we're going to take this one, the first one. Now, in this one, we can see that we have a square, thus we can deduce that we have an x squared, we have an x, and we have a number at the side. We can deduce that this is a quadratic one. It's a quadratic equation. So we'll need to put all of them in one side, minus 21. And what we need to solve here is solve for x. We're going to solve this taking the method of a trinomial factorial. So we're going to factor it like we factor a trinomial expression. So if you want, you can just remove this, and you can see that this is a trinomial. But now, since it has an equation, we call it a quadratic equation. So we're going to take it like this. We're going to say, we're going to open 2 brackets, an x, We're going to look at which 2 factors of 21 can give us 4. So which 2 factors of 21 can give us 4? We need to think. 21 has factors. We have 1, we have 3, we have 7. I'm not sure about the others, but already I can see that I have 3 and 7, and I can take these 2 and they can give me a 4. So we can say we're going to take the factors 7 and 3. Now the next question we ask ourselves is that which one receives which sign? Now since this is a quadratic equation that is a negative sign, we're going to have different signs here. Remember, when we have a minus, we're going to have a plus and a minus. But if we have a positive sign here, we're going to have the same signs. We're going to have either minus, minus, or a plus, plus. But in this situation, we have only one sign. So since we have a minus sign, we're going to have different signs. So which sign is going to receive? Which one is going to get a positive? Which one is going to get a negative? What you always do is the following. The bigger number gets the middle sign. So which here is a bigger number? 7 is our bigger number. Between 3 and 7, 7 is the bigger number. So we can see that 7 is the bigger number, thus it gets the middle sign, and thus 3 will get plus. So since this is an equation, we thus say, or, thus we have x is equals to 7, or x is equals to negative 7. So in the next equation that we have, we can, now this one is a bit of a tricky one. But remember the aim in equations. What we're trying to aim is we have to solve for x. So here I would say isolate x. So how do we isolate x in this? Remember that this is an exponent. In this equation, we need to take away 3. So if we divide by 3 in both sides, here we're going to have 32 is equals to x to the power 5 over 4. We need to solve for x, we need to isolate our x in this way. So when we isolate our x here, we can multiply this exponent with 4 over 5. Now since this is an equation, what we do on the other side, we need to do on the other side, on the other side. Sorry, what we do on this side, we need to do on the other side. That's one of the rules when it comes to equations. So we also here need to multiply this one. Remember there's a power to the power 1 here, to the power 4 over 1. So now we'll have 32, of course this is just going to be 5 log, is equals to x. But remember, we need to break this, we need to simplify it. We need to put it in we need to put it as a prime number. And a prime number that will fit in here is 2 to the power 5. Because that is the factor for 32 to the power 45 is x. And in this way, this is over 1. 5 and 5 will cancel each other. Thus we'll have 2 to the power 4 is equals to x. Then 16 is equals to x. We've solved this. What did we do? We first wanted to isolate, wanted to remove this 3, so we divided it by both sides. Then we wanted to isolate this x, so we wanted to remove this exponent, so we multiplied the exponents on both sides. Then when we got here, we needed to take this big number and put it as a prime number, so we put it as 2 to the power 5, and thus we dealt with the exponents, and thus we get 2 to the power 4, and thus we got 16. Alright, so the final one that I'm going to do with you guys is your simultaneous equation. Simultaneous equation is one form of equations that I've always loved. Alright? 7P took this from your past papers. So, in a simultaneous equation, one of the best ways to solve it is to first name them. This is equation 1. This is equation 2. Now, how do we solve a simultaneous equation? There are 2 ways. There's elimination and substitution. But we're going to use substitution because it's more faster for me. Personally, I believe that it's more faster. Let's take this equation. So we can try to isolate P. So we can take 2Q plus P is equals to 5. And let us try to isolate P, 5 minus 2Q. Now we've isolated Q, but now this is a new equation. So let us do it fast. We'll have equation 3. So the best way to solve this is to naturally substitute this equation into another equation, not the equation that it was derived from, because it's going to cancel out. So we're going to say 6Q plus 7, where there is P, we now put this, minus 5Q is equals to 3. 6Q plus 7, 7 to the power 5, 7 times 5, is 35, minus 14Q is equals to 3. Link them, this will give you 6 minus 14 will give you 18Q, and then when you take this one to the other side, we'll get 3, we'll get negative 32. So in this one, negative 32, we'll need to solve for Q. So if we solve for Q here, we'll definitely find that our Q is equals to 4. You can check this on a calculator. Negative 32 divided by 8 gives you, divided by negative 8 gives you 4. So now we found what 4 is. So we can go back. Now we can say Q is equals to 4. So now we're going to take this one, which has now made our equation 4, I like to call this equation 4, and substitute it in equation 3. So this one will be, so remember our equation 3, we had P is equals to 5 minus 2Q. Now we have our Q, so P is equals to 5 minus 2 to the power of 2 times 4, and this will give us minus 8, and thus this will give us a negative 3. So now we've solved this one, and we can see that our Q is 4 and our P is 4, and thus you've solved your simultaneous equation. Now thank you very much guys for watching this tutorial video that we did for you guys. We touched on a lot of things that are under algebra. We touched on algebraic expressions, we touched on exponents, we touched on equation, and we spoke about inequalities. We showed you how to solve them and how to do them. I would like, from the team, I would like to thank you. I would ask the team to please come up here so that we can say thank you as the team comes up. Thank you for watching our tutorial video. We hope that it helped you. Hope that you enjoy it. Thank you. Ciao.
Thank you very much, guys.